to solve for x, you need to get x on one side and, well, everyone else on the other side. So what you need to do, according to the videos, the homework, the person who is not connected to x, well, that's a 5. He doesn't even have an x, attached to him. So the first thing you have to do is throw across the positive 5 to get -5, right? So a few people forgot that when you throw something across, you usually get the opposite. So in a case like this, you're going to end up with 13 -5. Now, if you use your addition and subtraction rules from there, you will get +8 if you add up or minus this situation here. And of course, you have to remember addition and subtraction has totally different rules to multiplication and division, right? So if you don't put the positive sign here, but it's understood, right? So it's understood it's positive. From this point now, you have the 2, which is a multiply. Now, if the 2 is a multiply because it's touching the x, there's a secret multiply here. When you throw across the multiply, you get what? A divide. But on this side, the 2 is positive, but at the same time, he's a +2 being multiplied. Do I have to change the positive to a negative? What do you all think? Right, the answer is, right, Makaya, correct. Do I have to change that positive to a negative down here? Right, the signs will stay the same, because when you throw across a multiply, we always get a divide. It's just the signs remain the same, right? So +8 divided by +2, and this is how you write your final answer. Right, you had to say X number. At the end of the day, X ended up on one side by himself, right? So the answer is X is equal to 4, but you have to write it exactly like this, right? Right. So let's try another question, right? Just to the right of this, right? Let's see if you all can get this one out. Not much tricks in this one. 3 minus 4x is equal to -13. Try this question. Let's see if we can get this one out. All right. So the first thing we have to throw across is the person not connected to the x. That would be this 3. Now you have to ask yourself, is that 3 positive or is that 3 negative? Well, if you look to the left and you do not see a sign, well, then you have to assume it's what? Positive. That's the assumption in maths. So I think a few people forgot that that 3 is secretly positive. So when you throw across a positive, the opposite of a positive is a negative. So you see how I change the +3 to -3? So this is what we end up with now. -4x, because we didn't touch the -4x, and this minus sign belongs to that 4x. If you use your addition and subtraction rules, -13 minus 3 is -16. Some people put +16 here by mistake because they saw 2 negatives, and of course it's an old habit because of something you probably heard when you were in Form 1. You probably heard over and over that 2 negatives make a positive, but that's only if you are multiplying or dividing. Look at this situation here. We are not multiplying or dividing. So 2 negatives is actually give you back a negative. Addition and subtraction has completely different rules than multiplication and division. So from here now, right? This -4 is a multiply. When you throw across a multiply, you get what? A divide. But once again, when you throw across a multiply, the sign does not change. So now you ended up dividing 2 minus. When you divide 2 minus, then you get a positive. 16 divided by 4 is 4. All right. Of course, you don't have to put the positive sign. If you left out the positive sign, it's understood that it's living there. All right, so today you're going to be bouncing up these situations over and over and over in indices, right? And you're going to see how it's going to be mixed into the topic. All right. So as you all remember, we were trying to escape Port of Spain. So we went to where? The Caronia, the bird sanctuary, sorry. And we took a boat, and our hope was to sail out into the Gulf of Paria because we have to try to make it to Cedrus. So that's, well, we'll continue the journey a little bit later. All right, so the first question, we're not going to be doing all of these questions, but I want to take a look at number 4. So everyone write down number 4 in their books. And the aim of these questions is to solve for x. We're going to have to try to solve for x. So let me write back this question over here. All right. Oh, I'm going to put something else. If I have 5a is equal to 5 to the power b, right? I think last week I showed you when you have 2 same things on the other side, like the bases are the same, the items on top are equal to each other. I think that's why I ended class last week. But this only works if you have the same bases on both sides, right? So in a case like this, you can think of it like this, like the 5s will cancel out each other and it will leave you with a is equal to what? B. But it only works when it have exactly 1 base on this side and exactly the same exact base on the other side. So quick question. If I have 5a plus 5b is equal to 5 to the power c, is it okay to say a plus b is equal to c? You see on this one, I could have just put the a equal to b. What do you all think? The answer is no. That's a common trick. Remember, we said it only works for 1 and 1. How much do we have on this side? 1, 2. It only works when you have 1 base on each side. It doesn't even work for 2 on one side and 2 on the other side. It has to be exactly 1 and exactly 1 same base on the other side. So let me show you what would be correct. If I had 5 on this side, exactly 1 5, and exactly 1 5 on the other side, and then the power was a plus b, and this side was c. Notice you have exactly 1 base on this side, and exactly 1 base, and 2 of them are the same. In a case like that, then a plus b is equal to c. All right, so this one was wrong, but this one is correct. I want you all to take down the wrong one and put a big wrong sign by it, and then take down the correct one and put a big tick by it. Only works for exactly 1 on the other side and exactly 1 on the other side. No other situations. That's the only time you could put the powers equal to each other. Right, so let me know when you're finished with that. All right, so let's get started with question 4, the question that I really wanted to do. So in this question, we want to solve for x. So we have 3x divide, right? 2 squared is equal to 2 to the power 8. Now, if a person isn't too familiar with maths, they might quickly say, well, it have a 2 here, a 2 here, and a 2 here. Hey, all of them looking the same. So a person might be quick to cancel out all the 2's, and then they might say something like this: 3x divided by 2 is equal to 8. Is that correct, based from what I just said? Is it okay to cancel out these 2's and then just make an equation with the powers? Right, now we just said that's completely wrong in maths. We need to have exactly one big 2 on this side and exactly one big 2 on the other side. So we're going to have to try to find a way to squish these 2 together. It would be so nice if there was a way to squish these 2 together to get 1, 2. But you all already know a way. Let's look at the indices rules. Look at this. Look at this rule. Remember, we did this over and over. 2 weeks now, we've been doing that rule. Whenever there's a divide and the bases are the same, divide means you can minus the powers. So when you're dividing, you pull back the 2 once, which is good news because we only want 1, 2 on that side. Look at the rule here. When you have an x and an x being divided, when you're dividing it, you just only put the x once. And what do we have to do with the powers? Divide means to minus the powers. So we're going to have 3x minus 2. And this is equal to what? 2 to the power 8. Everyone understand so far? We just use this rule to squish these 2 together. Can we now make an equation with the powers? Is it okay to make an equation out of these guys now? What do you all think? Yes, now it's perfectly okay because you have exactly one big 2 here and exactly one big 2. So you can pretend that they disappear. They cancel out each other. And this leaves you with this nice equation now. 3x minus 2 is equal to 8. And your job is to solve for what? X. But you all already know how to solve for x because of the homework. So quickly solve for x. Get x on one side and everyone else on the other side. And send your answer. You might get a fraction. If you get a fraction, send it as a fraction. When you're solving for x, the first thing you have to do is throw across the minus 2. Now, a few people forgot when you throw across minus 2, you're going to get positive 2, right? So 3x is equal, x plus 2 is, 8 plus 2 is 10. But what do we do from here? Now we have to throw across this 3, but this 3 is a secret multiply because it's touching the x. And when you throw across a multiply, you get what? A divide. So you end up with 10 over 3. You can leave your answer like that, or put 3 and 1/3, or 3.33333, any way you want to write it. But the point is, you ended up with 10 divided by 3. Right? So any one of these answers will be correct. Okay, right, so take down the work. How about number 6? Now look at number 6 properly. You might say, hey, number 6 and number 4 real close. There's barely any difference between number 4 and number 6, right? It have the same, well, types of powers. Instead of 3x is 2x. Over here, instead of positive 2 is minus 3, but it have an 8. Work out this question. I want you to solve for x. It has a small trick in it. It's based on the same concept as number 4. But like I said, be on the lookout for a sneaky, sneaky trick. Right, and send your final answer over the chat. So number 6, let me write it back here. 2 to the power, oh, that's all 2. Yeah. 2 to the power 2x divided by 2 to the power minus 3 is equal to 2 to the power positive 8. Now, we know by now we can't cancel out all the big 2's because it's not 1 for 1 on each side. So we're going to have to find a way to squish these 2 together. And of course, we're going back to this rule over here. Divide means you have to do what with the powers? Minus the powers, okay? So we're going to pretend, make believe that if you get it correct, you will get $1 million, right? You'll wake up tomorrow with $1 million underneath your pillow, right? Let me just assume so. All right, so let's see who gets the $1 million. The powers are these guys here. Now look at it. This is minus 3. And you have what? A divide. So let's see what happens here. These are different color. So you have 2x here. Divide means to minus. But what weight in here? And next minus 3. So look at that carefully here. It looks like 2 minus signs because of the formula are going to touch. When 2 minus signs touch, you get what? A positive. And you have exactly 1 big 2 and exactly 1 big 2. So you're going to end up with 2x plus 3, because 2 minus, when they touch, they give you a positive. So this is the equation that you needed to solve. How much people could honestly say that they have that positive sign here? They realize that 2 minus signs will come in contact with each other. And that was a trick in the question, right? Right. So now you solve this, right? So you throw across positive 3 to get minus 3. So you end up with 2x is equal to 5, because 8 minus 3 is 5. You don't need to be real good in maths to know that, right? So, and now the 2 is a multiply, throw it across, you get a divide. So you end up with x is 5 divided by 2, or you could put 2.5. Any one of those answers would have been correct. The people who had 11 divided by 2, you all fell for the trick. You forgot 2 minus signs will give you what? A positive, right? So for those who got the make-believe $1 million, congratulations, right? All right, Destiny. All right. So multiply. We can't put the powers equal to each other because we don't have 1 for 1 on each side. But we have a way. Multiply means to do what with the powers? Add the powers. So it's 2 plus 8x. This one I don't think had any tricks in it, right? And it had a minus 3 there. Now you can put the powers equal to each other. So now I think it's okay to say 2 plus 8x is equal to minus 3. And I think a lot of people are getting the signs wrong here, right? When you throw across positive 2, you're getting what? Minus 2. So you're getting positive 8x and minus 3 minus 2. Remember, this is addition and subtraction. Eh? You're getting minus 5. Too many people put positive 5 here. And now the 8 is a multiply. We throw him across. When you throw across a multiply, when you throw across this, whatever you're throwing across, right? Whatever you're throwing across goes underneath. Some people throw it on top, right? The 8 actually has to go underneath. So this is your final answer, minus 5/8, right? So double check your work, while some people did get it correct, and the majority of people got it wrong. And it had to do with simple things like, hey, your mind told you 2 negatives make a positive, but you forgot that rule only applies to multiplication and division. This is addition and subtraction at this point, right? So let's look at those small errors, right? And let's make a mental note of it. All right, so you finally make it out to the ocean. For those of you all who have ever been in the Gulf of Paria, you can Whenever you're in the Gulf of Paria and you look behind, you could see the Port of Spain very, very clear, right? You see all the towers, all the buildings and everything. All right, so it seems that everything is good. You meet, and look, the explosion in the back here. Remember, when you were in Port of Spain, there was a little explosion. That's the smoke from the previous what? Explosion, right? That's the best picture of Port of Spain I could have found, which is not Port of Spain. All right, so hopefully everything will be good from there. This question, let's work out this question together. Write it down, and you're gonna need my help with this one. And unfortunately or fortunately, depending on how you look at it, it's gonna boil down to algebra again, solving for x. So the aim of this question is to solve for x, right? All right. So, oh, by the way, what was the answer for the last question? The answer for the last question was 518, right? Someone just asked me. Yes, the answer for the last question was 518. So, no, it was minus 518, sorry. So if you got minus 518, you are correct. If you didn't, well obviously it's wrong. So let's see what's going on with this question. Well, it resembles a you're seeing a multiply sign here. So it's going to have something to do with this rule here, a multiply. And when it's a multiply, it's okay to add the powers. Now, there are two things wrong with this question. First of all, we cannot put the powers equal to each other because it's two items on this side and one item on this side. But even worse, the bases are not even the same. It's not like it's 5 right throughout. So that's even a worse problem. For example, if I had 7 to the power 2x is equal to 3 to the power 5, is it okay? I know I have one base here and one base here. Is it okay to put 2x is equal to 5? What do you all think? I mean, you have one item on each side, right? So is that one okay to put 2x equal to 5? Right? The answer should be no, correct. Because the bases are not the same. If this was another 7, well, fine, no problem. You could have put both of them equal to each other. So let's make this question. Let me show you our next situation. If I had 7 is equal to 2x and 49 is equal to 5, we know we can't put the powers equal to each other because one is 7 and one is 49. But we know from primary school, 49 is the same thing as 7 what? Squared. So we could throw away this 49, pelt him away, and put what? 7 squared. And we just have to remember to put the 5 outside. The point is, when we throw away the 49 and we replace it with 7 squared, in maths, whenever you replace something, this is a general rule for the entire of maths. When you throw away something and replace it, you must put it in what? Brackets. That's a general rule. Now look at this. Look at the one with brackets. Look at this nice rule here. Remember last week I told you, when powers are separated by brackets, and these two are separated by brackets, it's okay to multiply the powers. The dot means multiply. So that means I can simplify this to 2 multiplied by 5 is what? 10. Can I now put the powers equal to each other? Is it okay? What do you all think? Yes. Now we can say 2x is equal to 10. Because you have exactly 1 7 here, exactly 1 7. Both bases are the same. So it's okay for them to disappear and leave the powers alone. So let's go back to this question now, right? We have 4x multiplied by 125 squared is equal to 25 to the power what? 12, right? Look back in your notes, right? I gave you a table. 125 can be replaced by 5 to the power something. 5 to the power what will give you 125? Just like how 2 squared is 4 or 2 to the power 3 is 8. 5 to the power what is 125? Right? Great. And it's 5 to the power 3. So we can throw away this person. In other words, if somebody had let me say you wanted to ask somebody for $125. You could be a normal person and walk up to them and say, good day, sir, can I have $125? Or you can be a weirdo and say, I would like 5 to the power $3. You're correct, eh? 5 to the power 3 is the same thing as 125. You didn't break the law. You're not breaking any mathematical laws either. This is also correct. But I guess then if you keep doing that, you're going to lose all your friends eventually, right? So, right. So there's 125. We could throw him away and replace him with 5 to the power 3. And who is lurking on the outside here? This square. 25, what can we throw away 25 and replace them with? Let me say somebody owed you $25, but you wanted to ask them a different way. You could ask them for how much money? 5 to the power 2. Well, 5 squared, you're correct, right? So you could throw away this 25 and replace them with 5 squared. Notice I put the brackets. And who's waiting on the outside? Mr. 12. So at least we're getting in a better position. At least everything have the base what in it now? 5. But we still can't cancel out the 5s because you have 2 of them here and 1 of them here. Everyone take them up to them. So according to this rule now, if there's a multiply, we should simplify it a little bit more. When powers are separated by brackets, like in these 2 cases here, we can do what with them? Multiply them. So 3 by 2 is what? 6. And 2 by 12 is what? 24. All right, so we're using this rule up here. Now it's going to be very easy. Multiply means to add the powers. So we're going to end up with 4x plus 6 because we get squish these 2 together and add the powers and put it equal to 5 to the power 24. Now you have exactly 1 5 here and exactly 1 5 here. Look at it properly, right? Squish these 2 together to get this using this rule. Exactly 1 5, exactly 1 5, right? Now we can form what? An equation. So let's put a little divide sign, a division sign. Someone said it won't be, just so that I understand your question, is you mean if this should be 25? You mean if this 5 should be 25? Right. So I've seen answers coming up. Some people are saying, and whenever you have an answer, you're going to have to reduce it for the examiner. If it could be reduced, you try your best to reduce it. So when you're solving for x here, you're throwing across the positive 6, right? When you throw across positive 6, you get what? Minus 6. So 4x is equal to 24 minus 6. I think that's 18. And this 4 is a multiply. throw him across, you get a divide. Now, you could simplify this to 9 on 2 because 2 could go into 18, 2 could go into what? 4. So you can put 9 on 2 or 4.5 if you want to put it as a decimal or 4.5, anyhow you want to write it. Right? So run through that back in your head. I know it's a long question, right? But to me, it's worth it, right? You all think it's going to run smooth? Any idea why there are fighter jets as you sail across the Gulf of Paria? You see ships, warships flying overhead. What do you all think is going on there? Any theories? You think someone launched war on Trinidad? Somebody said it's World War III. All right. So here's an interesting exercise, right? I want you all to look through the working. This student was given this question. 4x to the power 3 is equal to 2 to the power 9. And he was asked to solve for x. Now, he got 3 for his final answer. But something is wrong. His answer is wrong. I want you all to look through his working and tell me where he could have gone wrong. And just type an answer for me, like what you think the error is, right? To something. I'll use down here. We have a lot of space. If I have 2 to the power 3, and that's in brackets, and I have a 5 outside. Everyone knows that, well, from what I've been explaining, that whenever powers are separated by brackets, it's perfectly okay to multiply them. So since the 3 and the 5 are both powers and they are separated by brackets, it's okay to say 3 by 5 is 15. That's correct, and that's no tricks, no nothing. All right, so let's make it a little bit harder now. He's a different color. He's green. If I have 2 to the power 3, and that's in brackets, and then I have 2x plus 5 on the outside. Now that looks crazy, right? But it's 2 pieces of, it's 2 powers. The first power is 3, and the next power doesn't look too nice, but the next power is 2x plus 5. The point is, one section is inside the brackets and one section is outside the brackets. So the powers are separated by brackets. The rule still applies. We have to multiply these 2 powers. So if you look back at the homework now, we're really supposed to take the 3, this power, and multiply it by the power outside. But I'm writing this slightly wrong. Now I'm saying the correct thing. Remember, I just said we're supposed to take 3 and multiply it by the power outside. I did write that, but mathematically, I wrote it wrong. Let me explain why. What I'm trying to accomplish is this. I'm supposed to multiply this entire power, this 2x plus 5, by 3. To do that, I have to put this in what? Brackets. That shows the examiner that I want to multiply this entire thing by 3. If I do not put the brackets, you know what this means? This means you're only multiplying the closest person. So only the 2x gets multiplied by 3. So you will end up with this, 6x plus 5. But this is wrong because we want to multiply the whole thing by 3. So the correct thing is this, 2x plus 5. And if we do that, both items get multiplied by 3. 3 multiplied by 2x is 6x. And 3 by 5 is 15. You all see the differences between the wrong answer and the correct answer? Both of them have the 6x, but when you put the brackets, you get 15 here, not 5. Do you all see that mistake above here? Which line has the error now? Look back at it. Which line has the first error? Right, Anjana, correct. No, Faith, the error didn't appear as yet. No, Samia. Joseph, correct. Right. Elijah, correct. Faith, correct. Right. So let's pretend we're Jimmy. So Jimmy starts the question over here. That's line 1. But his next line, he realizes the bases are not the same. But Jimmy's a smart guy. So he says 4 is the same thing as 2 squared. So he puts that in brackets. And what's waiting on the outside? The x plus 3. So this is line 2. Notice there's no difference between our working and Jimmy's working so far. But his next line is wrong. Isn't he supposed to multiply this entire power by 2? Not just the first person. Look what he did by mistake. He take the 2 and multiply it by the x to get 2x. But did he multiply the 2 by the 3? Do you all see that mistake? What is this value supposed to be? Look at where what is called this little pencil I have here. What is that supposed to be? What mistake did he make? What am I supposed to replace this 3 with? 6, correct. It's supposed to be because we're multiplying this whole thing by 2. 2 by x is 2x. But what about Mr. 3? 2 by 3 is what? 6. And that's the mistake he made. So the first error occurred in line 3. Everyone sees that? That you're supposed to multiply everything here by 2, not just the closest person. Make sure you see it there. So now, do you all think you all can finish the question? You forget the rest of Jimmy working. Now that we have what? A 2 here and a 2 here, exactly 1, 2, exactly 1, 2. They can disappear. And you're going to end up with 2x plus 6 is equal to 9. You're just going to end up with the powers being equal to each other. Quickly solve for x and send me the correct answer. The answer is clearly not 3 because Jimmy got it wrong. You're going to get a different answer for x. Please let me know what that answer is. So when you throw across the positive 6, you're going to get what? Minus 6. So we're going to end up with 2x is equal, well, 9 minus 6 is what? 3. The 2 is a multiply, throw it across, you get what? Divide. So the answer is 3 on 2, or some people put 1.5 or 1.5. Any one of these answers would be correct. Quite a few people got it correct. Right. All right, so apparently there's some sort of beam that came from the sky and totally vaporized water spinning. And there's a little rumbling song in the background there. What do you think is going to happen there now? A huge tidal wave approaches now because of the explosion. All All right, so things shaping up there now for the action. Right, so the explosion caused a huge tsunami, and the explosion came from something in the sky. All right. All right. So here's a little quick, how you say, this is a kind of review exercise now, based on all the rules. But instead of whole numbers, I try to include what? Fractions. All right. So I want you all to try A and B and send your answers. This is 3 on 2, 1.5 and a half. Don't let the fractions frighten you. It's either you're adding the fractions, minusing the fractions, things that, well, you did in primary school, right? I just put the fractions because I know it would have freaked some people out. But just do A and B and send your answers. Right? So some people say it's an alien invasion. Who knows? All right. So for the first one, I'm reading the answers. Now here's a multiply, right? Now multiply means you can add what? The powers, provided that the bases are the same. And the bases are the same. One is the letter U, the other one is also the letter U. So what we have to do now is add the power. So you put back the U once, and then we say 3 on 2 plus a half. Now, is it 3 on 2 the same thing as 1.5? If you have 1.5 cakes and somebody gives you another half, how much cakes you have? 2. I think some of you all forgot how to add fractions. For those who got that one wrong, you understand the mistake? The answer is U to the power 2, U squared. Right? It doesn't matter of adding the fractions, right? The answer is not square root. Square root is different from squared. Square root is this. U square root. That's totally different from squared. That's the opposite of squared, in fact. All right, for those who got this wrong, you understand your mistake? You're adding the powers because multiply means to add. You're just adding fractions. 1.5 plus a half will give you 2, right? This one is almost the same thing. It's multiply, the bases are the same. So you're going to add the powers. 4 on 3 plus 1/3. Now, I'm just showing you how to add fractions, just in case to refresh your memory, right? If you have 4 on 3, and we are adding 1/3, the LCM here is what? 3. 3 into 3 is 1. 1 by 4 is 4. 3 into 3 is 1. 1 by 1 is 1, right? Won't we get 5 on 3 here? So the answer will be V 5 on 3, or if you want to put it in mixed fractions, V to the power 1 and 2/3. Any way you want to put it, right? I'm just testing the ability here to add fractions or minus fractions. That's all I'm doing. Okay. With that in mind, I want you all to try G for me. How much is G? Simplify the answer as much as possible. So it's G to the power a quarter, open brackets and 0. So these two powers are separated by brackets. Now, we did so much examples in a few minutes ago. When powers are separated by brackets, what do you do with them? You multiply them. So this is what you're already trying to do in your head. A quarter multiplied by 0, right? How much is anything multiplied by 0? Go back to your primary school. Did the back of your and the back of the copybook used to have this? Anything multiplied by 0 is 0. So you end up with, no matter how crazy it is, anything multiplied by 0 is 0. And if you look back on your notes on the first day, anything to the power 0 is 1. the final answer. No, the answer is not even G. Right? Oh no, Q. I put this is supposed to be Q. So I made a mistake. It's supposed to be Q, right? Sorry about that. They're a horrible update there, right? But anything to the power 0 is 1. Remember last time I gave you that, I gave you all a smiley face to the power 0 and the answer was still 1. No matter how crazy it is, anything to the power 0 is 1. Right. So the answer was, so how you would write it in the exam is like this. The final answer is equal to 1. Right. All right. So I don't have too much more to show you here. I wasn't planning to do all, right? But, right. Someone asked, okay, I want your opinions on this one. Somebody asked, if the final answer is Q to the power 1, if I wrote that as my final answer, would that be correct? That is 100% wrong. Because anything, because I know that when we multiply the quarter by 0, I am getting a 0 on top here. If we multiply it and get 0 and the answer is physically 0, why are we putting 1? That's like saying 0 and 1 is the same exact number in maths. They are completely, obviously it's two completely different numbers, right? And plus Q to the power 1 would give you Q. Anything to the power 1 is itself. So if you put Q to the power 1, you are already saying the answer is Q, when the answer is supposed to be 1. Q and 1 cannot be the same thing in maths, right? So I hope that answers the question, right? Don't ever make the, and this is not the first time I encountered this, right? Where people think 0 and 1, for some strange reason, is the same number, right? It's obviously not the same number. I don't know why that confusion comes. I'm already not too sure. All right, so for the person who asked the question, you're clear on it now? See what's next on the list. All right. All right, so luckily the tsunami didn't kill you. You were able to, you were overturned, you lost your boat and whatnot, but there was an oil rig close by. But the Gulf of Paria has a lot of oil rigs there. Right, so you survive by floating on a little box there. And of course, you're going to swim to the oil rig, which has survived. That's the best thing best case scenario, I guess. All right, now I'm going to end off class here because of something, but I have some homework for you all, right? If you all will notice that on the screen here, we have a lot of what? Fractions, okay? How much of you all think you are super, super comfortable with fractions? Like I could give you any fraction to add, multiply, and divide, and you could do it quickly. All right. So before we actually do these questions, right, I need to make sure everyone is really, really comfortable with addition, subtraction, multiplication, and division of fractions. Now, in the homework itself, right, the video is 1 to 7. There were some questions where you had to multiply fractions. But remember, that's more of an algebra exercise. That wasn't a full tutorial on what? Fractions. So now I'm going to give you the official homework on fractions. So everyone just pay attention here. I think everybody knows by now how to reach on the school website, right? The iLoveLessons and whatnot, right? So when you go in the maths classroom, right? And I have a full tutorial on fractions, like every single thing you need to know. By the time you're done that tutorial, nobody could fool you on fractions. So scroll down to the video of topics. Scroll down until, oh, the fractions right here. It's lesson 2. It's only 1 video. Don't worry. It's not 21 videos. It's not 7 videos. Everyone make a note of the homework. Fractions is lesson 2. I need you to watch that video and get really, really accustomed with everything you can do with fractions. Multiply, divide, add, subtract, simplify, everything. Okay? Even if you think you're comfortable with fractions, I guarantee you, when you watch that video, you'll see a whole set of new things, tricks the examiner can play on you. All right, so that's mandatory homework, right? It's due for next week, right? The video isn't too long. I think it's just 45 minutes long, right? And this is where it's very important to keep always doing the homework. Let me explain what's going to happen now for the people who didn't do the previous homework. Because some people did not do videos 1 to 7, and that's still outstanding. Now you have more homework on top of that. It's like you have a sandwich and you have too much homework in it now. So you have 1 to 7 fractions. You're going to slowly realize, because you let the homework build up, now you're going to have too much homework. And it's going to be super frustrating, right? So my advice is get started on the homework as fast as you can, because in a couple of weeks, you're going to have more homework. And then you know what's going to happen? You're going to tell your parents, "Sir, giving you too much homework and the class is too stressful." But it wasn't my fault. It was your fault for not taking care of the homework in small pieces and gradually make it doable. All right? So get started, because when your parents call me, I will have this on recording and I will explain to them why it's too much homework. There was no fault of mine. It was the fault of the students. All right? So guys, get started on the homework. I'm not going to be able to call your parents. I know I wanted to talk to some of your parents, but I'm going to have to do that later. So later I will call the student parents to discuss the homework and whatnot. Okay, so guys, that's pretty much it for today, right? If you're not clear on what the homework is, Saeed, you can stay back. I will re-explain the homework. All right, everyone else is free to leave.